Welcome back, folks. Rational expressions and equations, lesson 9, solving problems involving rational equations. So the problems that this unit focuses in on are basically distance, speed, time problems. Okay, so distance, speed, time. And if you know anything about all of that, that's velocity. Maybe some of you that have taken physics already know how this formula kind of works. Here are some brief guidelines. One, read the problem carefully and understand what's being asked. Obviously, introduce a variable to represent an unknown quantity. Sometimes we'll use letters from the problem. Sometimes it'll be D, S, and T for distance, time, and speed, because sometimes it's easier to understand. Write an algebraic equation, in this case, a rational equation, to represent the given information. Solve the equation, and then of course verify or check to make sense, make sure that your answer makes sense. Okay. So example 1. So this triangle here represents our speed formula. Speed is equal to distance divided by time, and we can use that within these word problems. Okay. Example 1. Competing in an endurance race, Shannon cycled for 120 kilometers, then swam for 12 kilometers. Her average cycling speed was 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. So what do we know? We know that she cycled 120 kilometers. We know that she swam 12 kilometers. Her speed at cycling was 8 times her speed swimming. So if we say that S is her speed for swimming, then her speed cycling would be 8s. Now, if I use my distance, speed, time formula, okay, distance, speed, time formula, I know that distance divided by speed is going to equal time, right? So I can say 120 divided by 8s is equal to the time it would take her to cycle. 12 divided by s would be the time it took her to swim. Now it says that her entire race took 9 hours, right? It took 9 hours, which means if I go 120 over 8s plus 12 over s, this should equal 9 hours. Well, look, now we have a rational equation. Again, we do the same process, determine the common denominator, which is 8s. 12 over s was over here, 120 over 8s was already there, is equal to 9 over something. It was originally 1, but we are going to multiply in an 8 here. So this is going to be 12 times 8. We're going to multiply an 8 and an s here. So this is times 8s. Once we have everything on a common denominator disappears. I'm left with 120 plus 12 times 8 is 96 is equal to 72s, and I can solve. This is 216 is equal to 72s. Divide by 72, divide by 72. That gives us a nice even s, 3. S is equal to 3. So s is, at her speed is 3 kilometers per hour. Done. Okay, now the toughest part is setting up this little chart, figuring out what goes where, right? So you always start with filling in the chart and then try and determine the rest. Example 2, St. Andre Students' Council is traveling from Knoxtown to Harperville for the Students' Council National Conference. From the travel budget allowed for the trip, the St. Andre's Student Council has 2 options. They can leave tonight by bus, or they can save 3 hours by leaving tomorrow morning using the express train, which travels 20 kilometers per hour faster than the bus. If the distance between Knoxtown and Harperville is 1,500 kilometers, determine how long it would take to travel by express train. So I'm going to set up a table. I'm going to call this, let's draw a table. Distance, speed, time, distance, speed, time, by bus, by train. We know the distance is 1,500 kilometers. We want to know what it's going to take by each, right? 1,500. My speed for my bus I'm going to call S because I know that my train is 25 times faster than that. Or 25 times, yeah, not 25 times faster, sorry. It goes 25 kilometers per hour faster. 25 plus S, or S, I'm going to rearrange that, S plus 25. That comes from this statement here, travels 25 kilometers faster. Now, what's my time? Well, it would be 1500 divided by S, or this would be 1500 divided by S plus 25. And we know that the train, we know that the bus or the train can save 3 hours. The train can save 3 hours, which means our bus time, can't spell bus, my bus time minus my train time should equal 3 hours. Well, my bus time is 1500 divided by S. My train time is 1500 divided by S plus 25. That should equal 3 hours. Now I have a rational expression and I can solve. Again, actually, we didn't do it in our not over here, but we didn't do a non-permissible value, did we? Speed cannot equal 0. Obviously, if it's 0, then it's not going to do anything. Here, S, speed cannot equal 0, or speed cannot be negative 25, right? But my common denominator is, so what's already here? S is already here. S plus 25 is already here. 1500 was already here. 1500 was already here. 3 was already here. This is technically over 1. My common denominator is S times S plus 25. So that goes here, S plus 25. S is not here, S goes here, and they both go here. All on the same common denominator now. I can scratch it right off, and I can expand some brackets. Bomb here, I'm gonna multiply those together. I'm gonna bomb this and bomb, oh no, don't do that, bad arrow. Bomb the 3 times the 5 and then multiply that into that bracket. Okay, so I'm gonna get 1500S, oops, wrong color, 1500S plus 37,500. That's a minus 1500S equals 15 times S plus 25. Simplifying the left-hand side, the 1500s will cancel. That just leaves me 37,500 is equal to 15S plus 25 times 15. 25 times 15. No. Well, that's not a 5, that's an S. Oops. Back up. This should say 3S. So this is going to be 15S squared minus 75S. My S's look like my 5s. Subtract 37.5 from this side, 37.5. Subtract 37.5 from this side, and factor. 0 is equal to 15S squared minus 75S minus 37,500. I think I've still done something wrong. Totally. This is 3S times S. This should just be 3. This should be 3. Which means this should be 3. That's better. I'm going to factor out a 3. So if I divide each of these by 3, I'm going to divide this side by 3. 0 is equal to S squared minus 25S minus 12,500. And I'm going to factor that. Two numbers that multiply to give 12,500, add together to give 25 is 100 and 125, with the 125 being negative. S minus 125, S plus 100. And then I'm going to solve. So I'm going to move over here, provided I can make that bigger. S minus 125 is equal to 0. Add 125, add 125. S is equal to 100, not X. S is equal to 125. Take my other one, S minus 100, not minus, plus 100 is equal to 0. Did I get that wrong? Got something wrong. Because that's not minus. Geez, I'm really screwing this up. This should be plus 75. This should be plus 75. This should be plus 25. That makes that plus 125. And this one should be minus. So when we solve over here, there we go. This should be plus. This should be minus. This should be minus. And that's where we're at right now. This speed of negative 125, speed equals negative 125 kilometers per hour. That doesn't work, does it? Okay, so this is basically a solution that does not work. So we can ignore this one. We don't need it. We don't use it because it's negative. But I go S minus 100 equals 0. Add 100. Add 100. S is equal to 100. So the speed is actually 100. Okay. Now, the question actually doesn't ask for the speed, does it? It asks for how long it would take to travel by train. So the speed, how long the time for the train is going to be 1,500 over 100 plus 25. So I figured out speed to be 100. So that's 1,500 divided by 125, which is equal to 12 hours. Okay, that takes us to the end of lesson 9. Also takes us to the end of the rational expressions unit. Checking Stellantis for the work that needs to be completed, and we will see you next time.